My name is Dr. Connie Arps. I have a PhD in organic and medicinal chemistry, and I'm currently the chairman of the Scientific Advisory Board for HGI Industries. In the middle and late 1990s, research from the military, universities, and the government in atmospheric chemistry revealed that one of nature's most powerful oxidants had been unknown because it was so small and so reactive, and they were able to, with advanced laser technologies, to analyze it and determine that it was called a hydroxyl free radical. The chemistry is rather simple. It's produced from the interaction of the sun's UV radiation with oxygen and water vapor in air, and the net effect is to strip off one hydrogen from H2O and end up with HO, with a free electron. That's a very fast-acting oxidant, very powerful, and in essence, it's seeking to get back that missing hydrogen atom that was stripped off. And in doing so, it reacts with nearly all the organic chemicals that make up the polluted air that we breathe, and it kills microorganisms like bacteria, viruses, mold, and mildew, and restores the balance in nature's air so that it's safe and healthy to breathe. Without it, our air would essentially be unbreathable. Because it's formed in a very high-energy process, it is able to abstract a hydrogen atom from almost any kind of organic chemical. It also is able to disrupt the cell membranes of microorganisms, causing them to leak out their fluid, a process called lysing. And so between these two processes, what you end up doing is oxidizing the volatile organics. These begin to come apart like the beads in a string of plastic pearls. The chains get ever shorter, and eventually, as they continue to react with the hydroxyls, you produce carbon dioxide and water from even long-chain hydrocarbons and volatile organics. When a hydroxyl is formed and the UV radiation it absorbs results in it being basically stripping a hydrogen atom from water, that OH radical has a high capacity for pulling off another hydrogen from almost anything else. Its oxidative potential is second only to that of elemental fluorine. It is such a potent oxidant. And so every volatile organic chemical that it comes in contact with that has a free hydrogen atom, it will abstract that, transform itself back into water, and that organic compound then becomes a free radical in its own right. It rapidly reacts with oxygen and begins to decompose like the beads in a plastic string of pearls. They keep coming apart until gradually you can oxidize it and completely transform it into carbon dioxide and water. It takes a while, but since this is a continuous process and nature produces between 2 and 10 million hydroxyl radicals per cubic centimeter on a sunny day, there's plenty of these hydroxyls to interact with the sea of organics we produce naturally and artificially through industrial activity, and gradually the air is restored to a natural and safe balance. Now with microorganisms, it's a slightly different procedure. Their cellular membranes, unlike our skin, are not evolved to be insensitive to hydroxyl radicals, and microorganisms' cell membranes are disrupted. They begin to leak their internal fluids in a process called lysing, and they're destroyed. We've evolved symbiotically with hydroxyls and all the byproducts that are produced in our atmosphere, and our skin is impervious, our mucosa is impervious, and we actually benefit from having them present. They act as a natural bactericide. These hydroxyls kill bacteria, viruses, mold, mildew. It is probably what enables us to stay healthy and enjoy the outdoors. Very different from the indoor environment. The minute you open a window and expect to get fresh air in, what you're really getting is a stream of air that basically has been already cleansed of the hydroxyls. They react within 50 to 100 milliseconds with the volatile organics present. And there's so much organic load in air that they don't last very long. So if you want hydroxyls and the benefits that they provide outdoors, indoors, you have to generate them artificially. And that is the observation that was made by HGI about 15 years ago, when they realized that they could recreate the balance of nature indoors using high-performance optics in a device that would continually refresh and produce hydroxyls indoors safely and match precisely the concentrations that you would find outdoors. The minute you turn the machine off indoors is the same as what happens when the sun sets. Hydroxyls cease to be produced. Well, as long as the device is running, there's a continuous creation process for the hydroxyls. They are interacting with the VOCs in the chamber of the device where the UV optics occur, and they also do so to a certain distance outside. It is this cascade of volatile organic byproducts that are formed that help the process, because each successive oxidation product, as in nature, is a little more stable than a hydroxyl would have been. It can travel a little further, and it acts as a free radical oxidizing agent as well. These all get circulated back through the machine, and you're constantly destroying and shortening and eliminating these volatile chemicals. So it really is a free radical chain reaction that is quite unique to the hydroxyl as its initiator.